Hello, geometry students. In this video, we're going to take a look at our 8.6 notes where we're going to learn a couple of laws of trigonometry that will allow us to solve for missing parts of triangles that are not right triangles. So far, the trigonometry that we have been studying is called right triangle trigonometry, but today we'll be looking at triangles like, for example, this letter A, where we're asked to find x, which is the side of a triangle that is not a right triangle. So the laws that we learned today, called the law of sines and law of cosines, will allow us to do that. So first of all, I just want to say one more time that we're going to use the law of sines and law of cosines that will allow us to solve triangles that are not right triangles. So you might want to underline that or highlight it or circle it, or just make sure that you remember that everything we do today applies to triangles that are not right triangles. All right, so let's learn our first law. It's called the law of sines, and here's what it says. Well, first of all, we'll use this law when we're given a triangle and given the following information about the triangle. We know a couple of angles and we know a side. So it could be an angle side situation or an angle side angle. Doesn't really matter, but if we know a couple of angles and one side of a triangle that is not a right triangle, that's when we would use this law. And here's what it says. If we have a triangle ABC that has side lengths A, B, and C, so notice, for example, little a is the measure of the side opposite angle A, and little b is the measure of the side opposite angle B, and little c is the measure of the side opposite angle C, then if we have triangle ABC with side lengths little a, little b, little c, which are opposite angles A, B, and C, then the following is true. The law of sines says that we have, if we take the ratio of the sine of angle A to the measure of the side opposite angle A, that ratio would be equal to the sine of angle B to the measure of the side opposite angle B, and that is equal to the sine of angle C to the measure of the side opposite angle C. So that's our law, and you'll notice that what that does is it sets three ratios equal to each other. So to solve a problem like we'll do in just a minute here on example A, we would just pick two of these ratios, set them equal to each other, and then we'd have a proportion we can solve. So let's take a look at example A, and you'll notice that it asks us to find x, and we're also asked to round our answer to the nearest hundredth. So this is clearly a calculator problem. So if you take a look at angle A, notice what we're looking at. Well, first of all, this is not a right triangle. We're given two angles and one side. It's the two angles and the non-included side. So that's an angle side situation, and that's the perfect time to use the law of sines. So if we're going to use the law of sines, we're going to write a proportion. So what we're going to do is we're going to use angle A because we know the measure of the side opposite angle A. And then we're going to use angle B because we're looking for the measure of the side opposite B. So here's what the law of sines would say. If I take the ratio of the sine of angle A to the side opposite A and set that equal to the sine of angle B and put that over the side opposite B, that ratio would look like this. And this step that I just wrote down, you could certainly skip this step and go ahead and write this next step, where we would say the sine of angle A is 78 degrees, and we're going to put that over the measure of the side that is opposite angle A, so that would be 8. So the sine of 78 over 8 is equal to the sine of angle B, whose measure is 60, and then we'll put that over x because x is the measure of the side that's opposite angle B. Okay, so if you take a look at this proportion, it's an easy one to solve. So we'll cross multiply and divide. Well, let's go ahead and do just one step at a time. When we cross multiply, then we would have the sine of a 78 degree angle times x is equal to 8 times the sine of a 60 degree angle. Okay, so now what we want to do is solve for x. X is being multiplied by the sine of 78, so we'll divide both sides by the sine of 78. Okay, so now it's calculator time. The sine of 78 cancels on the left side. So we would end up with x is equal to, now when you go to type this in your calculator, now when you're working on an Inspire calculator, I just want to remind you of the keystrokes control. If you hit the control button and then hit the divide button, then you'll be able to type this in as a fraction. So I just highly recommend you do that. And so when we take 8 times the sine of 60 and divide it by the sine of 78, our answer rounded to the nearest hundredth would be, and let me change this x to approximately equal to 7.08. So if you take a look at example B, notice we're being asked to find x, which is opposite angle r. So the first thing we're going to need to do is find out the measure of angle r. Well, we can do that because we know the sum of the three angles is 180. So if you add up 37 and 54 and subtract that from 180, you're going to get 89 degrees. All right, so we're going to write a ratio that involves angle r, or excuse me, the sine of angle r and x. And then we need to set that equal to a ratio of an angle on the side opposite it. So why don't we use angle S, because we know the side opposite angle S. All right, so our ratio would look like this. We'll take the sine of angle R, which is 89 degrees, and put it over X, and that's going to be equal to the sine of the 54-degree angle divided by 8. Okay, so we just took the sine of R over X is equal to the sine of S over 8. So we write that proportion, and now we can cross multiply and solve. So we'd have, let's see, the sine of an 89-degree angle times 8 is equal to X times the sine of a 54-degree angle. So to solve that equation for X, we would divide both sides by the sine of 54 degrees. Okay, sine of 54 degrees. And then use a calculator again. I'm going to turn this around and put my X on the left. So you would calculate that on a calculator, round it to the nearest hundredth, and you should get approximately 9.89. Example C is another example of a problem that we can solve using the law of sines because we know two angles and we know one side. This one happens to be an angle side angle situation, but we can solve x by writing a proportion using the law of sines. So it looks like we're going to want to use angle T and then the measure of the side opposite T, and then we'll use angle S and the measure of the side opposite S. So the first thing we're going to do is find this missing angle. So if we were again to add 31 and 64 and subtract that from 180, then we should get that our missing angle is 86 degrees. All right, so using the law of sines, we're going to write a proportion. We're going to say that the ratio of the sine of angle T, which is 86 degrees, over, so the sine of angle T, which is 86 degrees, over 14 is equal to the sine of that 31-degree angle, which is this angle, opposite the side that over the side that is opposite the 31-degree angle, so that would be over x. Okay, so once you get your proportion written, then we will solve it by cross multiplying. So we would have the sine of an 86-degree angle times x is equal to 14 times the sine of a 31-degree angle. And then since we're trying to solve this equation for x and it's being multiplied by sine of 86, let's divide both sides by the sine of an 86-degree angle. Sine of 86. So we would get that x is approximately equal to, when rounded to the nearest hundredth, would be 7.23. The next law we're going to look at is the law of cosines. And this is a law that we use when we're given two sides in an angle or three sides. So if it's a side angle side or side situation of a triangle that is not a right triangle, then here's what the law of cosine says. If triangle ABC has side lengths little a, little b, little c, which are opposite angles A, B, and C, then the following is true. Okay, so this theorem has three parts to it, and I will tell you that at first it looks a little scary, but once you've worked with it for a little bit, you'll see that it's really not that complicated at all. So the first part of the law of cosines has to do with side A, and here's what it says. It says that a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of angle A. All right, so that looked kind of scary, but again, you'll get used to this really quick. So little a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of angle A. So that's part one of the law of cosines. Part two of the law of cosines has to do with side B. So it says that b squared is equal to a squared plus c squared minus 2 times a times c times the cosine of angle B. Notice that when you start with a squared, you end up with the cosine of angle A. When you start with b squared, you end up with the cosine of angle B. So that brings us to the third part of the law of cosines, which has to do with side C. And it says that c squared is equal to a squared plus b squared minus 2 times a times b times the cosine of angle C. All right, so what you'll do is we'll use this law to solve some problems, like in just a minute we'll do this example A, where we're given two sides and an included angle. So we will use this law of cosines to solve for x. So let's try this first example where we're again going to find x, and we're going to round that answer to the nearest hundredth. All right, so if we're looking for x, let's start with x. And the law of cosine tells us that x squared is equal to the sum of the squares of the other two sides, which would be 15 squared plus 19 squared, but don't stop there, keep going, minus 2 times 15 times 19, and then times the cosine of, now since we're looking for x, that means we're going to end this with the cosine of the angle opposite x. That's a 125 degree angle, so we'll say the cosine of 125 degrees. All right, so to get our solution then, notice that x is being squared. So since x is being squared, if I want to know what my answer is, I need to take the square root of both sides. So in other words, we can say that x is equal to the square root of 15 squared plus 19 squared minus 2 times 15 times 19 times the cosine of 125 degree angle. So at this point, you'll grab a calculator and you can do all this arithmetic in one step. So punch all this in, punch in the square root symbol, and then punch in this whole huge radicand. And then you should take that answer, and the directions say round it to the nearest hundredth. So we should get that x is approximately equal to 30.21. And then let's continue with example B. This time we're being asked to find x. Okay, so let's start with that, and we will say that x squared is equal to the sum of the squares of the other two sides, which would be 7 squared plus 4 squared minus 2 times 7 times 4 times the cosine of, now we're looking for x, so that means we're going to end with the cosine of the angle opposite x. So that would be the cosine of a 62 degree angle. So the cosine of 62 degrees. All right, well, if x squared is equal to all that, then if we take the square root of both sides, we would get that x is equal to the square root of 7 squared plus 4 squared minus 2 times 7 times 4 times the cosine of a 62 degree angle. And then, of course, you don't have to write both of these steps. If you want to just jump to this step, that's perfectly fine. But on your homework and tests and quizzes, I would want you to actually write down what you're calculating before you put it in the calculator. So write that down and then find your answer rounded to the nearest hundredth would be approximately 6.22. Now, as we take a look at letter C, you'll notice that this problem is a little different in that, unlike the last two problems, this time we're being asked to find an angle. So just like when we were doing right triangle trig, if you're asked to find an angle, you might want to be thinking that at some point we're going to have to use an inverse trig function. So you'll see that we'll need to do that. But let's go ahead and set up this problem. And since we're looking for this angle M, whose measure is x degrees, that means you want to start with the measure of the side opposite the angle that we're looking for. So we're going to start this with this 8. And the law of cosines says that if we take 8 and square it, that's going to be equal to 6 squared plus 3 squared minus 2 times 6 times 3 times the cosine of the angle opposite that 8, that leg that side whose measure is 8. So that would be the cosine of angle M. We don't know what that angle is, what that angle measure is, so we'll just put an X in there. So you can see how if we're going to find out what X is, we're eventually going to have to use trig ratio, an inverse trig ratio. But before we do that, what we want to do is we want to isolate this cosine of X. We want to get that by itself on one side of the equal sign. So what that means is this 6 squared and this 3 squared are going to have to be subtracted from both sides. So I'm going to go ahead and take 2 steps to do that. Let's start by just moving those two terms over. Then we would have, we would have 8 squared minus 6 squared minus 3 squared equals, now what I did is I just subtracted 6 squared and 3 squared from both sides. So these would be gone from the left side. So what remains starts with this negative sign. So we would have negative 2 times 6 times 3 times the cosine of x. Cosine of x. Now remember, let me put parentheses around that x. Remember, we're trying to get this cosine of x isolated. You'll notice that cosine of x is being multiplied by negative 2 times 6 times 3. So let's divide both sides by, let's divide both sides by negative 2 times 6 times 3. Negative 2 times 6 times 3. Okay, so all that will cancel on the right. And so what we would have is 8 squared minus 6 squared minus 3 squared divided by negative 2 times 6 times 3. And that is all equal to the cosine of an x degree angle. So now, if I know an angle's cosine, which I do, remember the cosine is the ratio of two things, right? So a cosine is equal to a ratio. If I know an angle's cosine and I want to know the angle, that's when we use an inverse function. So to find x, x is going to be equal to cosine inverse of this whole ratio. Cosine inverse of 8 squared minus 6 squared minus 3 squared, all divided by negative 2 times 6 times, I noticed I wrote a C there, up here. Sorry if I confused you and wrote C there. That should have been 3, right? We're dividing by negative 2 times 6 times 3. So let me fix that, and my apologies if I confused you. And so now what we're going to do is grab a calculator, type in cosine inverse, and then don't forget about that control divide key combination so that you can type in cosine inverse of a ratio. Be really careful as you type it in. Make sure that you don't miss this negative sign. And our answer, rounded to the nearest hundredth, we're going to follow directions. X would be equal to approximately 121.86 degrees. All right, so what we're going to find in the next problem that we do is I'm not going to write all this algebra out. I took it step by step because I didn't want to lose anybody, but you'll see in the future that you won't have to write quite so much to solve for a missing angle using the law of cosines. So let's take a look at one more example. This last example asks us to solve triangle ABC, rounding each answer to the nearest degree this time. That would be the nearest whole number. Okay, so if you look at the triangle, remember solving a triangle is finding any missing parts. Well, a triangle has 3 sides and 3 angles. Notice that we're given the 3 sides And so to solve this triangle, we need to find the three missing angles. So let's just make a list of what we're being asked to find. We need to find the measure of angle A, we need to find the measure of angle B, and we need to find the measure of angle C. So what we'll do is use one of our laws, and let's talk about which law we want to use. Well, notice we're not given any angles here. To use the law of sines, we need to know at least two angles. So clearly we're going to have to use the law of cosines, and we'll actually use the law of cosines twice. Why don't we use the law of cosines to find angle A, and then we'll use the law of cosines to find angle B. And then if you want to use the law of cosines at that point to find angle C, you're welcome to do so, but we don't need to, because remember, once we know two of three angles of a triangle, we'll be able to find the third by just subtracting their sum from 180. So let's start with angle A. So if we're going to find the measure of angle A, we need to start with the measure of the side that's opposite angle A. So we'll start with this 15 squared. So we're going to, using the law of cosines, we're going to say that 15 squared is equal to 13 squared plus 12 squared minus 2 times 13 times 12 times the cosine of, now we want the cosine of the angle opposite the side that measures 15. So that would be the cosine of angle A. And since I don't know what that angle is, why don't we go ahead and call that angle X degrees? Okay, so cosine of angle X. All right, so now, as I said in the last example, we're not going to write everything out, but let's talk about what we need to do. If we want to isolate this cosine of angle X, we need to get these two terms moved to the right, so we'll subtract 13 squared and 12 squared from both sides. Then we need to divide by the coefficient of cosine X, which is negative 2 times 13 times 12. So let's do that all in one step. And so what we would get is we would get that the cosine of an x degree angle is equal to 15 squared minus 13 squared minus 12 squared, all divided by negative 2 times 13 times 12. Now in the last example, we took 2 or 3 steps to do that. So let me just make sure I didn't lose anybody. I subtracted a 13 squared and a 12 squared from both sides. Okay, move those over to the left by subtracting. And then I divided both sides by negative 2 times 13 times 12. Be careful that you don't lose this negative here. Okay, so that means that x, I'm going to turn this whole thing around and write it with the x on the left. X would be equal to cosine inverse of that ratio of 15 squared minus 13 squared minus 12 squared, all divided by negative 2 times 13 times 12. So grab a calculator, punch that in. Now remember, these directions said round to the nearest degree, so that means that x is approximately equal to a 74 degree angle. Okay, so that gives us the measure of angle A. So the measure of angle A is 74 degrees. Okay, so now let's take a look at, let's find the measure of angle B. Okay, so why don't we call the measure of angle B, why don't we call it y? Okay, so to find that angle whose measure is y degrees, let's start with the measure of the side opposite angle B. So let's start with 12. And so the law of cosines says that 12 squared is equal to 13 squared plus 15 squared minus 2 times 13 times 15 times the cosine of that y degree angle. All right, so that means to find out what y is, y would be equal to cosine inverse of, now what we're going to do is we're going to again subtract 13 squared and 15 squared from both sides, and then divide that, all of that, by negative 2 times 13 times 15. So y is equal to cosine inverse of 12 squared minus 13 squared minus 15 squared, all divided by, be careful, don't lose this negative out in front of the 2, all divided by negative 2 times 13 times 15. All right, and then we will put that in a calculator, round the answer, remember, to the nearest degree. So y turns out to be approximately 50 degrees. All right, so y is 50 degrees. And then, as I said earlier, if you want to use the law of cosines just for the fun of it to find the measure of angle C, you're welcome to do that, but it's not necessary because we know that C, the measure of angle C, is just the rest of the 180 degrees. So we'll add 74 and 50 together, subtract that from 180, and our final answer then will be 56 degrees. All right, so those are the three missing angles, so we have solved triangle ABC. Okay, so if you have any questions, be sure and ask me in class. Otherwise, you can go ahead and get started on your homework. Did I post it on here? There it is. You can go ahead and get started on your homework. That will be posted in Google Classroom, and you'll get some help in class next time. And I will see you then.